Okay, what we're going to look at here is angular speed and linear speed to describe circular motion. That does not sound like the very best title, but anyway, here you have a circle here, and you have this point here, and the point is moving along the circle. Now, let me just sort of fill in some of the... All right, so maybe I said it too fast, but you have this point, and it's moving along a circle. So the positive direction is counterclockwise, negative would be counterclockwise. No, positive is counterclockwise, negative is clockwise. So we have R as the radius, that's pretty familiar. S is this arc length. Theta is in radians. So there's 2 pi radians in a circle. So in this picture here, this looks like to me it's about 1/8 of the circle. So this would be 1/8 of 2 pi. So that's around pi over 4. So to find out the radians, it's the fraction of the circle times 2 pi. Okay, so as a point moves along a circle with radius r, its angular speed omega, it looks like a W. I sort of feel like calling W, but it's angular speed, and that's omega, is the angular rotation per unit time t. So omega is equal to theta divided by t. So it's, it's how many degrees, or it's not degrees, but how much angle per time. So it's how fast that angle is growing or shrinking in a given amount of time. And so notice this doesn't depend on how large the circle is. There's no R here. Okay, so that's the angular speed. So all right, I'll just write here, angular speed. And then the linear speed which is V of the point is the distance traveled which would be the arc length S per unit time t. So we're going to get V is equal to S divided by t. And so recall that S is equal to R theta. This is a formula that we've talked about. So if that's true, V equals S over T, which is going to be R theta over T, which would be R theta over T. So therefore V is going to equal to R omega. So this is linear speed. So if you multiply the angular speed times the radius, you're going to get the linear speed. A water wheel completes one rotation every 5 seconds. Find the angular speed in radians per second. So the solution is to understand that one rotation is equal to 2 pi radians. So once around the circle is 2 pi. So omega is equal to theta over t. So omega would be 2 pi over 5. So this would be radians per second. Here's another example. A bicycle has wheels 28 inches in diameter. Okay, so a bicycle has wheels 28 inches in diameter, and then a tachometer determines the wheels are rotating at 180 RPMs, which is rotations per minute. Find the speed of the bicycle as it travels down the road. Okay, so we have a lot of things going on here. Well, I think that the idea would be that if you can find the linear speed of this wheel, that should be how fast it's traveling. So we need to find the linear speed, v. We have that v is equal to r times omega. Omega is the angular speed. So omega is equal to theta over t. In our situation, it's well, in our situations, we're going to do 1 minute here for time. Okay, that's the easy one. And then it's 180 rotations is theta. But theta is not going to be given in rotations. It's going to be 2 pi. So notice that there's one rotation equals 2 pi radians. Okay, so that takes us closer to something that looks like closer to finishing this problem. So that's 2 pi radians per minute. Okay, so almost, well, maybe, I don't know, it seems like we're almost there. Okay, so I have omega, and I can use this formula that V is equal to R times omega. So let's just remind ourselves what R is. So we're going to use, we want to use V equals R omega, and we have what omega is right there. R is 1/2 of the diameter. So R is going to be 1/2 of 28 inches. So therefore R is 14 inches. And so V would be 14 inches times, and by the way, I don't see that. Let me start over here. Okay, we're going to use V equals R times omega. R is 1/2 of the diameter, and R therefore is 1/2 of 28 inches, which is 14 inches. So I'm going to really want to work on units because it could help to try to get things right. So I'm using R times omega. When I say it's 14 inches, that's 14 inches per radian. Every radian is equivalent to 14 inches. So every circle has, the radius is 1 radian when you're using the radian units. So it's 14 inches per radian. And then omega, which from the other above there, is 360 pi radians per minute. Okay, so I wanted to do this so I could get everything to, units all working, canceling, and so forth. So the radians cancel out. So I have 14 times 360 pi, and then it's therefore going to give me inches per minute. Now, that could be okay, but it might be a little bit unsatisfying to have, those units. So, so we could try to convert that to something like miles per hour, I suppose, for if we feel like it. And well, but let's just, anyway, while we're at it, multiply 14 times 360. So this is 5,040 inches per minute. And okay, so fortunately this is, I probably want to use miles per hour. And but that would require that I know how many inches there are in a foot, and then I guess I'm going to have to remember how many feet are in a mile. Okay, so, and I'll drop the 0 by mistake here. So this is going to be inches per minute. And so then, well, first of all, let me try to do 60 minutes per 1 hour. So I'm going to get that in miles, or no, it's going to be inches per hour. So apparently this is going to be 302,400 inches per hour. Now, if I take that guy there and I multiply that there's 12 inches per 1 foot, then the inches will cancel out. Inches and inches will cancel out. But then I have to remember how many feet there are in 1 mile. And that's 5,280. And this really, illustrates why people like to use the metric system. So, because if we were not using the metric system, I think these unit conversions would be easier for sure. Now you can maybe use your oh, by the way, I dropped something here, which is pi. So I have to multiply by pi. So, yeah. Okay. Okay, so I got 14.9939, etc. So that's about 15 miles per hour. Okay, so I would say that I learned, this is learning how to do this problem, but also it's just a lesson of what are we still using these feet, miles in the United States? Why aren't we just using the metric system? But there we go.